Hi, welcome to this training video on universal functions. A universal function is a function that performs element-wise operations on data in ND arrays. The universal functions behave as post-vectorized wrappers for simple functions that take one or more scalar values and produce one or more scalar results. To begin with, create an array of range 5. To take out the square root of each array element, use URT method, that is, the square root method of numpy. It takes arguments and keyword arguments. To take an exponential of each element, use exponential function, that is, np.exponential, inside the parenthesis, pass the data. To take out the maximum value in a one-dimensional array like this, use max function, that is, np.max. Similarly, use minimum function to get the minimum value of array. These universal functions, which takes one array as the input, are referred to as unary functions or unary universal functions. We can also apply universal functions on two or more arrays of data using extended form of universal functions and are referred as binary universal functions. Let us see how these binary universal functions works. In order to show how this works, let us create two arrays of same size or shape. Now use maximum function and use these two arrays as the arguments, that is np.maximum, and then pass the data 1 and data 2 as the arguments. This will compare the two arrays and gives the maximum among the two in each array. For example, the first element in data 1 is maximum compared to the first elements in data 2. Hence, the first element in data 1 is taken as the maximum element or the maximum value. Similarly, the second element in data 2 is greater than the second element in data 1. Hence, second element in data 2 is taken as the maximum value, and so on. Let us create one more array to show the remaining universal functions, that is, data 3. The mod f universal function will return the fractional and integral parts of the floating point array. Here I have created a floating point array. Let us use the mod function on this array, that is np.mod, and then separate the fractional and integral part by using the identifiers fraction, integral. Let us check the fraction part and then the integral part. If we try to take out the square root of this floating point array, sqrt function may return nan for the negative values and gives warning for us. Let us see what is the warning. Invalid value encoded in sqrt method. Suppose if I convert the negative values into positive values using the absolute function, that means by using the absolute function, if we convert all the elements of the data 3 into an absolute values, we can use the square root method on these array values. Since we have converted all the array elements into positive values, so we won't get any error or the warning message. The square root function similarly returns square of each element. If the number consists of more zeros after the decimal point, negative over is used to represent the decimal distance of that value. The rint function will round off the floating point value to an integer value by keeping the negative sign unchanged. In other words, it rounds elements to the nearest integer, preserving the data type. The ceil function computes the ceiling of each element, that is, the smallest integer greater than or equal to that number. Let me display the data first and then use the ceil function. Now, let us see how we can use arithmetic universal functions to add, subtract, multiply, power, and divide the arrays. So let me create two arrays of same shape first. that is data 4 and data 5. The add universal function will add the two arrays element-wise. The subtract universal function will subtract the arrays element-wise. Here, in the subtract method, the second array elements are subtracted from the first array elements. That is, data 4 array elements are subtracted from the data 5 array elements. The multiply universal function will multiply each element of one array with the corresponding element of the another array at the same index position, element-wise. This is the major difference between the dot product and the multiply functions, where dot product performs matrix type multiplication, whereas multiply will multiply each element of one array with another array of the same shape. So no need to transpose rows into columns unlike the dot product. So let us multiply data 4 array elements element-wise with the data 5 array elements. Similar to like multiply, divide universal function divides the first array elements by the second array elements, element-wise, instead of the Python traditional floor division. This returns a true division. True division adjusts the output type to present the best answer regardless of the input types. The power universal function will power the first array elements using the second array element as the powering integer. In simple, it raises elements in first array to powers indicated in the second array. So let us raise the elements in data 4 with the powers indicated in the array elements of data 5. The greater universal function will return the Boolean array indicating whether all the elements in the first array are greater than the second array. If first array elements are greater than the second array, then results true, else false. Let us check with the above two arrays. Let me displace the two arrays first and then use the greater function. Here the data 4, that means the array data 4 is not greater than the array data 5. Hence it results false. If we interchange the arrays, that is data 5 and data 4, we will get true because data 5 array is greater than the data 4 array. Similarly, we can apply the universal functions to an higher dimensional arrays and practice well. Thanks for watching this training video. I recommend you to continue with the series of training videos.